This video is going to demonstrate a way that you can look at what is coming into a decision flow as far as the object and be able to use that on your guards to make a decision and then follow whatever flow comes out of it. So we'll look at it in terms of an object flow and in terms of a control flow where there's no actual object coming out to whatever's happening at the end. This is something that I've tried to do many times and finally cracked it, but let me execute it first so you can see what it looks like in the end. Then we'll talk through how it works. I'm going to execute, and you'll see we're creating an object of one type. It's coming in. It's moving too fast to explain, but you watch and then we'll go through it one thing at a time. Here comes flow object A. Now we're going into the object parser. It's looking at that object and determining that it was flow object A and following that. It's just this is just a sample activity to show how this would work. All right. So the end result, obviously, is that you can create objects of different types, and then even though it's a token, which is really like an instance of an object flowing in your simulation, you can essentially meta-chain from that instance backwards to find the block or the class, but in this case, a block that types it, and use that block object itself on a guard to evaluate. So the basic setup here in this example is I have two blocks. One is doing the parsing, and one is just providing the objects into it. And they both live in this context here, which is executing that activity of them passing it back and forth. The real important thing to note is this flow object, where I have a generic flow object and then two specialized versions of it, one called flow object A and one called flow object B. That becomes important because this is what we're looking at in our little parser to determine if when something comes in, if it's type A or type B. I'll start with the control one over here first. When we're getting a flow object, and you'll notice that this activities parameter is of the generic type, which means it could be either just a generic flow object or type A or type B. It comes into a decision node as a decision input flow. Now, in many scenarios, that decision input flow isn't important and is even kind of a hindrance in trying to simulate your model. But in the case of what we're doing now, it's imperative. You have to have your object coming into the decision node as a decision input flow, with a control flow also coming into it. And then you have your outputs as you normally would. However, the outputs are not actually as normal as they might look. If I come to the specification, we have guard over here, and typically you would write an expression or something, but what I've done is instead you click on the little arrow and you do a value specification element value, and then you choose the block, which for me was flow object A. You pick that as your guard, just the object itself, no Boolean expression, just the object. And then likewise flow object B over here. Now, the only reason that this works is because there is a little used feature of a decision node called the decision input. If I open this up, you don't see it in Expert. You see the decision input flow, but if I expand this, and let's look for input here, there's this secondary property called decision input, and that needs a behavior of some type. So what I've done is I've made an activity that just lives free floating in the containment tree right here. It's called get type of token, and I have put that into the decision node as that decision input. So let's look at what get type of token does. What get type of token does is it's just taking a generic input, and you'll notice I don't have it typed. I'm trying to make this as generic as possible to use in as many situations as possible. So this could accept anything, really. It comes in, and I'm just calling it token. Then there's an opaque action, which is performing this method to navigate from the token to the block, in our case, that is typing it. So we're going from some random instance that has an @ sign followed by a lot of numbers and letters as the ID. It's going and grabbing the block type and then outputting that right here as type as the return value. Now that return value is what becomes the object that the guards are looking at. So we've input an instance and then output a block. And so now it's looking to see, is that block the same as this block? Is that block the same as this block? And when it finds the one that matches, it'll follow that path. The logic is 99% the same if you're trying to actually have your object then come back out. You have the object parser. It's the same thing you'll see, except for now these are object flows instead of control flows right here. The only difference is how you set up what's coming into your decision node. Because now what is invoking the decision node and what is being passed through is an object instead of a control flow. So I'm forking the object here and having one instance of it come into the control flow and then come back out unchanged. So this is what comes in and this is what comes out. It doesn't change. By having this additional input stereotyped by decision input flow, this one comes in, participates in the get type of token activity, comes out transformed, and is used to evaluate the guard to see if it's flow object A or B. But to reiterate, what actually comes along this object flow and into signal C is the instance, the runtime object that you put in right here, not the block definition anymore. It's an instance. That's pretty neat, in my opinion, that can work that way. So I'm reusing in this setup. I'm reusing the same activity in this example scenario here. 2 times I'm running the control parser, so you can. One time it gets a token that's typed by object A. One time it gets a token that's typed by object B. And you can see that it makes the decisions correctly. And then again, it does object parser, calls that twice. Something to note, though, is that for object parser and control parser, they're both using this one single activity called get type of token. It's the same activity and could probably be used in many different types of scenarios, just doing this one little thing. I'll slow it down so we can just watch it happen in real time. So once again, we're creating an object, which is an instance of flow object A. Flow object A is coming into our control parser. The control flow is telling it to go to this decision node. We have our stereotyped decision input flow so that it comes into this decision input behavior, gets evaluated here and transformed into returning its type. That type is then evaluated against the guards. It found flow object A, so it sent signal A. And then we repeat, except this time it's flow object B. Control flow coming into the decision node. Then you have flow object B getting evaluated. Well, an instance of it getting evaluated. Then you're returning flow object B, the classifier, not the instance. And it chooses flow object B. Now again, object A, same type of thing. It's an instance of the classifier. This time though, we're splitting our object flow. One is coming in as the input to the decision flow, and one is coming in just as an object that's going to be unchanged. Get the type. Now it's checking that transformed version against the guards, but the token that is flowing out to signal C is not a transformed version. It is just the instance of flow object A, and now this time it's going to be the instance of flow object B. And I will actually pause it when we get right before the signal D here and show you that it's an instance of the block. Okay, so let's come into here. Take one step forward. All right, so now you can see on this right here, right there, flow object B at whatever. That's the ID of this instance. So that's a handy way to be able to use your decision nodes to make complex decisions based on the input they are receiving using objects and not just strings and booleans and primitive value types like real and integer. One other thing to note here is whenever you're simulating in your model, there's a whole bunch of various options that may impact what happens. Those are up under options and then project. You can find it in the quick down here or simulation. One of the ones that in specification changes how a decision node acts is this FUML engine. So there's a whole OMG spec about this. And you'll notice when you look at this, even in Magic Draw, it says the difference, but if you turn this on versus turn it off, it says the difference is that instead of evaluating a Boolean at each guard, it is just matching whatever you have coming out of your decision node against the object. So it's a nuance. You don't have to make a Boolean expression with a double equals or a less than or greater than, right? You're just matching the guard to that. But in practice, when I put this together, it behaved my simulation exactly the same way, whether this was set to false or to true. So it may make a difference in some other things, but in this at least particular case, I noticed no difference between having FUML decision semantics on true or on false. Thanks for watching.